based on our last concept phase. So one of those things that we've talked about is that we're gonna use a angle bar. The width is 38 millimeter and the thickness is about 4.5 millimeter. I also decided to use a 1-inch CRS. Now the reason why I use CRS is because it is completely round. There's many kinds of shafting. There is one that is hot rolled and they're not really round, they're a bit oblong. I'm gonna use what we call a pillow block bearing. This is how it looks like. I already got two of these. So if you buy a CRS that is 1-inch, it can fit perfectly here. Their fit is so perfect that if you have some burrs here, or if your shaft is really dirty with a lot of dust, you're not able to put it in. Fits perfectly. So I haven't done any CAD work for this project yet. I really made sure that this is going to be as authentic as possible. So I don't know how long it's gonna take, to design this sheet metal bender, but I'll try to do my best. So I will start with the static portion of the bender. So I'll just get my right plane and I begin to sketch the section of the angle bar. So you notice that I did not put the section right smack at the center. It is only constrained here, so I cannot move it sideways, only upwards. There's a reason for that because let's say this is 15. Because if this is the rotation of the shaft, right? Yeah, if this is the shaft, let's say that's 25.4 mm. And then if my stationary angle bar is like that, it's gonna interfere with the shaft. That's why I have to place my stationary angle bar. I need to offset it so that it will not interfere with the shaft. Maybe yeah, I guess 15 mm is okay. So let's exit that and try to extrude this. So maybe I'm comfortable with 400 mm. I'm looking at my measuring tape now and looking at, is 400 okay? Yeah, I guess 400 is okay. So this will be our stationary component. I don't plan to do any stress calculations for this one because I think it's gonna be complicated when I try to solve it by hand. The thickest sheet metal that I would probably bend is maybe around 1 millimeter. So if I have material that is much bigger than 1 mm, like for instance this one 4.5, maybe, I'm saying maybe because we don't know, but hopefully it is more than enough strength so that this will not bend or deform while doing the bending action. So this is the piece that will be rotating. Now you'll be wondering, how come I am making the moving piece, which is a separate part, in the same part model? So the reason for that is that I'm using a technique called Body's technique. Let's say I extrude that at maybe 300. Untick this merge result. When you accept it, it's not gonna be merged with your current solid. So if you try to look at the cross section, it's completely separated. So later on, I will show you how to actually create this into a separate part. And then, of course, the shaft will be attached here like this. And then, let's say 25.4 mm, let's say 100 mm. It's too long, maybe 50. Unmerge. So it's gonna be like that. Where will we place the bearing? Will it be here or on this side? I guess it has to be on this area here, because if you're gonna put it here, then it will interfere with this area. Maybe we can color code it para hindi siya confusing. So sometimes you want to do this to color code it so that you know the parts that are, moving or rotating or fixed. I like green. So let's try to use green. Yan. So the green ones are moving and the gray one is the stationary. Yeah. So I don't know about this. Maybe it's not a good idea. So I set this as 300, right? And then this is 400. So there are two independent parameters. So what I've discovered in designing is sometimes you want to have one parameter dependent on another parameter. For instance, if you just want to maintain a distance between this surface and that surface, and then we want to maintain it constantly, instead of setting this length, we can set its offset distance here. Example, offset from surface of this surface. Yan. And then let's say, ilalagay ko dyan, let's say 20 mm. So it will set it like this all the time. Then I just have to do it on the other side. The same thing, offset from surface 20 mm. Check. There. So it's gonna be like that. I'm not very happy with this kind of connection kasi this green thing will be welded. What we can do is we can actually cut this and then uh, parang expand this on that side. So edit this and you can place direction 2. Let's say I'm okay siguro with 20 mm. It's gonna be welded there with a 20 mm weld bead. Maybe it's okay, maybe it's uh, strong enough. Sige, let's decide na 30 na lang. So it should be strong enough. Again, it's not merged. What you have now is that karon siya ng interference here. You can just simply cut this, I guess. You can do cut extrude just like this. So this is just gonna be a rectangle. Now I know that this has to be 12.7 because the shafting is uh, 1 inch, which is 25.4, and half an inch is 12.7. So this is the cut extrude. Again, I'm gonna do it up to surface of this so that it'll just follow wherever the shaft goes. And then sa feature scope, I untick this to make sure that it will only cut this angle bar and not the shaft. Yeah. Why did I decide to cut it like this? Because this is just a simple straight cut. I can cut that by a grinder. And I can cut this bottom area with a grinder as well. So right there, I already considered manufacturing effort or how am I going to fabricate this. So, uh, so yeah, so I keep on thinking about this. In reality, guys, whenever you design, it's not like this. Kasi this one is like a, you know, when people play games and then they video it, playthrough. So this is like a playthrough of design. I haven't seen a video like this in YouTube. That's why I'm making one. I think that it will be useful for our students or whoever wants to do actual design. I'm actually just stalling because I'm keep on thinking about this. I think we don't need this gap anymore. Probably we don't, but I'm not sure. But let's try. So this is the thing about design. Things could actually change. Instead of offset from surface, I'm just gonna do up to surface so that it's like right smack at the surface. It's the same with this one, up to surface. But that's on the other side. So it's gonna be like that. So I will just mirror that later. Let's focus on one side. So if we're gonna do it like this is the stationary component again, and this is the rotating. We could probably put the bearing right here, and it's not gonna interfere with any other elements. So this is 50 mm if I'm not mistaken. So the question is, will 50 mm be enough for our bearing? So you could just model the bearing. So to do that, in most bearings, you need to get its H. I don't know the H of this, but I will pause the video first and I will download a data sheet for this particular bearing.